Nassim Haramein was born in Geneva, Switzerland and is now based on the big island of Hawaii. From as early as 9 years old, he was developing the basis for a unified hyperdimensional theory of matter and energy, which he eventually called the hollow fractographic universe theory. He has spent most of his life researching the fundamental geometry of hyperspace. Combining this knowledge with a keen observation of nature, Nassim discovered a specific geometric array that is fundamental to creation. His unification theory, known as the Haramein-Rauscher metric, is a new solution to Einstein's field equations that incorporate torque and the Coriolis effects. Together with his recent paper, The Schwarzschild Proton, his theory lays down the basis of what could be a fundamental change in our current understanding of physics and consciousness. In the past 20 years, Nassim has directed research teams of physicists, electrical engineers, mathematicians and other scientists. And he's been giving lectures and seminars for over 10 years. He's founded a non-profit organisation called the Resonance Project Foundation, where as Director of Research he continues exploring unification principles and their implications. The foundation is actively developing a research park in Hawaii which combines science, sustainability and green technology. It's a great pleasure to have Nassim here. Where'd he go? There he is. First time in Australia at a Nexus conference. Please give him a big warm welcome, Nassim Haramein.
Thank you. Thanks for having me. It's great to be here. Thank you so much. I thought there was going to be translation into Australian, so, I haven't practiced but good day, mate. Not bad. I'm getting there. All right. Today we're going to learn a little bit about the Schwarzschild Proton. This is a paper I just published last year, and it won an award in Europe, which is good. I was surprised. The director of the conference came up to me. He's like, in the middle of the conference, I thought I was going to get kicked out of the conference, and, because it was a pretty radical paper. It was an invited paper, so I thought, oh, I can go radical because, they can't refuse it if it's invited. And, he took me aside in the middle of a conference, and it was in Belgium at the math department, and I thought, that's it, here it goes, And he's like, I noticed on your schedule that you're leaving before the award presentation, and I thought, oh, yeah, I had set it up on purpose that way because, it's like, I'm sure I'm not going to be part of that. And he goes, we'd like you to stay. I'm like, why? And he's like, well, you won the best paper award for physics. I'm like, really? Wow, we live in a new paradigm. And, why was I thinking this was radical? Well, you'll see why. And I'm just going to go through it a little bit. And please don't panic. But we're going to do a little bit of math. It won't hurt. It's only going to hurt momentarily. But then it's okay, It's not permanent damage. This really started when I was about 9 years old, and I went to my first geometry class at school. It was, I was not doing so well at school because I had all these esoteric experiences, and I, lived in a world in which, I was interacting with all sorts of things and all sorts of worlds out there, and I was more interested in that than what the teacher was saying. So most of the time I didn't pay much attention, so I didn't, I wasn't doing so well. And when the teacher went to the blackboard that morning and said, today we're going to have our first lesson in geometry, and the first lesson in geometry is dimensions, I was like, oh, adults know about other dimensions? I was like so excited, and then I got so disappointed. Because the teacher went to the blackboard and made a little dot like this and said, this is dimension 0 and it doesn't exist. And I was like, oh, this is not gonna go well. I knew from that moment on I was gonna fail that class. Because I was way back, I was always nearest the door. and I could see the dot. So if I could see the dot, how is it that it didn't exist? And then the teacher did something remarkable. He put a bunch of dots together, made a line, and said, this is dimension 1, and it doesn't exist either, because it still doesn't enclose volume. And then he put 4 lines together, made a plane, called it 2D, and said that's the plane that all your comic strip books lives in, and it doesn't exist. And I could see, like, the kids were crushed, you know. They were like, what? And then he did something miraculous. This is the equivalent of the, you know, miraculous Big Bang, you know. He did something miraculous. He took 6 of these planes, put them together to make a cube, called it dimension 3, and said, this one exists. And I was like, huh? How did that happen? You know, because I don't care if you put 100 million non-existing planes together, you don't get existence, right? If the dot that doesn't exist, right, makes the line that doesn't exist, makes a plane that doesn't exist, you don't get existence. You get non-existence to the 4th. Big issue. I didn't know at the time. Turns out many other thinkers had the same problem throughout the ages. One of them, one of the most famous one, was Buckminster Fuller. Another one was my father, actually, turns out. And, you know, they thought about it, but nobody really solved the issue. And so, why is this important? Well, this is actually the fundamental axiom that most of our physics are written on. And if we, in the math, we write those physics with. So if we have this wrong to start with, if it's incorrect or if it's incomplete, then we're going to get an incomplete or incorrect picture at the end. And so, because people learn this very early in their education, it's usually not revisited ever by the physics community. And at the end of the day, then they have superstrings theory and Calabi-Yau spaces trying to solve equation for unification for advanced physics, and they have to add, you know, planes of freedom one after the other to get like 248 dimensions of Calabi-Yau space, and the equations go on forever, and at the end of the day it doesn't add up. Right? So when I was going home from that day, I had this long bus ride to go back to my home because I kept on getting kicked out of the schools closer to my home. A physicist later on told me in a physics conference that that's how I furthered my education. Because I had all this time to think about it, right? And so I'm sitting there, I've got an hour and a half to go, and I'm thinking, man, I got to solve this dimensional problem. This is not happening. I can't live with this. And I'm thinking, and then the bus is getting fuller and fuller, and I thought, oh, you know, it's getting hot, and so I closed my eyes, and in my mind's eye, I extruded myself from the bus, and I started rising up from the bus, and I saw slowly the bus becoming smaller as I rose further and further, and then I saw the city I was in becoming smaller as I rose further and further and further, and then the continent getting smaller, and then I saw the earth getting smaller, and as I rose further, I saw the solar system getting smaller, and like looking like a dot, and then I rose further and further, and then the galaxy started to look like a dot, and I thought, oh my God, it's dots all the way up. And then I flew back into the galaxy and looked at the solar system and flew back in and went back to the earth and found the bus I was in, and I opened my eyes and I looked at my hand and I thought, I wonder what's in there. I closed my eyes, and in my mind's eye, I flew into my hand, and I saw it was made out of millions and millions of dots. We call cells. And then I went onto the surface of one of those dots and looked really carefully, and I got finer and finer, and eventually it opened up like it was stars of dots everywhere. Billions of them that we call atoms. And then I went to one of those dots, and I looked in the middle of it, and sure enough, what was there? Another dot. And I was like, oh, it's dots all the way down. And I had this epiphany, like, oh my God, maybe the universe, maybe the answer to the riddle is the exact contrary. The only thing that exists is a dot. The universe makes points of infinite division and assembles them at different scales and make everything we see. I was like looking at the people in the bus, and I could see they were made out of dots and smaller dots and smaller dots. They seemed to glow with a strange aura, and at this moment. And when you have these moments of epiphany, I'm sure many of you in this room had them, you know what you want to do next, right? You want to tell someone, right? And you all know how that goes, usually. You get the look like, did you take your medication this morning? And, so I ran home when I got out of the bus, and I waited for my mom to come back from work, and when she got home, I was like, Mom, I figured out something at school today, it's so awesome. And my mom was all excited, like, oh my God, he's actually enjoying school, like, oh, maybe he had a good exam, for the first time in his life. And I'm like, Mom, today I learned about dimension at school, and they're wrong. I just went over like a lead balloon. And it's like, Mom, I think it's the contrary, that like the only thing that exists is dots, and you're made out of dots that are made out of smaller one and smaller one and so on. You get infinite amount of dots, Mom. And she looked at me, and she said, you know what, I just worked for 8 hours, I'm real tired, I don't feel infinite at all. And, she had made a point, pun intended. And it's like if everything is embedded into each other to infinities, how you get boundary condition? How does things differentiate from each other? This has been a big problem. It's a chasm in our understanding. How does infinity and finite system interact? Typically we think they don't. And that has shown up in our physics really strongly. So now we have a theory for like big stuff, Einstein field equations, that predicts continuums towards singularity, continuums towards infinity, and we have a theory for the small stuff, for the atoms and the subatomic particles we call quantum theory, and quantum theory predicts bounded linear finite states. So the two don't agree. And so since then we have this thing, and so we have this chasm between the two. Einstein tried to put it together, but he couldn't. And, the problem is that when you look out there, big things are made out of small things. So obviously, those physics must match. Right? Well, the chasm is much deeper than that. The chasm between the understanding of infinity and bounded state shows up in our society everywhere. I'll give you an example. Spiritual people tend everywhere. I'll give you an example. Spiritual people tend to think in terms of infinity, that like this infinite potential, that all things have infinity within them and all this. And the scientific community tends to think in bounded, closed systems of finite, rational concepts. And so the two don't agree, typically. The chasm even goes deeper. I think the deepest of that chasm is the difference between female and male. Women typically think in terms of continuum, in terms of curvature to infinity, like infinite possibility. Everything is okay, honey, right? And man thinks, in general, have a tendency to think in bounded state, you know, finite, highly logical systems. And the two can, in some cases, not agree. Statistics on divorce can support that statement, right? And so, but how do you solve it? I mean, there must be a solution, because men and women are here, because scientists and spiritual people are here, because large things are made out of small things. How do you connect infinities and finite systems? And I started to think about it at that age. By the age of 11, I was kind of despondent because, you know, I wasn't fitting in so well in society, and so I was not so happy, and I was actually pretty well ready to exit stage left, you know. And I met, luckily, a master of meditation that was not much older than me. I think he was like 15 or 16. And he taught me how to meditate. And when he taught me how to meditate, I learned that you can turn your senses from the outside to the inside, and you can go towards the center, and you know, there's a whole world there. And as I thought about that, I thought, maybe the solution between infinities and finite system is that there's stuff going in and then there's stuff going out, and the two, you know, meet and create boundary conditions that we think are finite boundaries. And so I start to extrapolate on that, and later on I realized that there is a simple geometric solution to the riddle. So in a simple geometric solution here, I'm going to prove to you that infinities and finite system are absolutely related. Actually, one cannot exist without the other. And so we'll make a boundary. We'll call it a finite boundary. This is a circle. And it encloses a certain volume, right? It could be a sphere in the space. So don't reduce it necessarily to a circle. And then inside it, we're going to put an equilateral triangle. Now that triangle in a sphere could be a tetrahedron. Everybody knows what a tetrahedron is? It's one of these, right? And we can polarize that tetrahedron because the universe has spin. Things spins in the universe, and when they spin, there's polarity. So it's okay, you can polarize it. So you can polarize the triangle. And interestingly, right away, you got an ancient symbol that you can find in many, many different cultures all around the world, although it's best known by the Jewish culture as the Star of David or the Star of Zion. Well, if you look carefully, you find that as soon as I polarized the first tetrahedron, I created new boundaries that have the exact same geometry that I started with. Except these boundaries are one step smaller, right? They're one gradient or one iteration smaller. Well, what's important to remember here that each of these boundaries define a very specific center, right? Like this boundary here, this is its center and this is its center, and all of the centers are all different from all other centers. That means that each of the boundary, although they are part of a similar geometry that is interactive with each other, meaning one cannot exist without the other ones, they all have their own very specific coordinates in space-time, and they observe the rest of the fractal structure from its own very specific point of view that no other boundary in the system has. You all following this? It's an important point. Now, you can polarize those, and you'll get smaller boundaries again. And again, each one is a very individual boundary. And you polarize those, you get smaller ones, And you can go to infinity doing that. So if I had this program running on my computer, it could keep zooming in and making more boundary and zooming in and making more boundaries, and it would go to infinity. Like, as long as the computer was running, it would keep going. However, I would never, ever, ever, ever escape or exceed the first boundary I've made for myself. So within the context of a finite space, I've embedded infinite amount of information. Infinite amount of divisions. That means that if this is true, and if it's geometrically true, and if it's mathematically true, then it most likely is true. You could take the boundary of any of your atoms, or the boundary of your cells, and divide them and divide them and divide it to infinity, meaning that you have an infinite amount of information, an infinite amount of divisions within yourself. So all of a sudden, you're starting to have a mechanical and mathematical understanding of the infinite nature of your existence. It's no longer just a metaphysical concept. It's no longer a belief or a dogma. It's actually a mathematical equation. Does that make sense to you? So this is crucial, because without it, you're still in dogma. And so, what does it mean to physics? I mean, it means a lot to spirituality and philosophy. But what it means to physics is that if physicists understood that, this simple example, they would stop building accelerators. We keep thinking that we're going to find the smallest particle. Not so long ago, a few centuries ago, we discovered the cells, right? And we thought, oh my God, cells are so small. They must be the smallest thing the universe does. And then we realized cells were made of billions of atoms, and atoms are so small. We thought, oh my God, that's got to be the smallest thing the universe does. The God particle. And then we found, oh, the God particle is made of smaller particles, protons, neutrons. And we went, oh, and they're like bitty little things in a very small thing to start with. And it was like, oh, that's got to be the God particle. And then we found subatomic particles and so on and so on. And it's like, wait, and every time we're finding these new particles because we're building larger and larger accelerators so that we can accelerate particles at faster and faster rate and collide them together to get smaller and smaller and smaller particle. And now we've built a device that's like an accelerator that's 17 miles long. I think it's cost like $10 billion at this point or something. It's extreme. It took like 5 countries to finance it. And we're thinking we're going to find this final particle, and it's like, and guarantee you there's some smart person out there that's going to find a new way to write the equation and go, oh, maybe there's something smaller. We need to build a larger accelerator. Well, those things have a finite limit, meaning like there's constraints on what we can build. So maybe instead of looking for a fundamental particle, a God particle, we should start looking for a fundamental pattern of division. Because if we understood the pattern, then we would understand how the universe creates. We would have the key to the divisions of the space that produce our reality, we would have the key to creation. That could be fairly useful. And so I started to think about that, and I was like, wait, let's ask a fundamental question. If you were asked to point at something in the universe that connects all things, what would you point at? What would it be? If you had all the universe, everything you see, and I asked you, find me something that connects all things, because you hear that a lot in the spiritual world, and from masters that in ancient times and so on, that everything is one, right? But how? If you don't tell me how, then it's just a concept. It's just a dogma. You got to tell me, how is that possible that everything is connected? Like, you got to explain that to me.
Consciousness.
Well, if you say consciousness, you haven't explained anything, because probably every person in this room has a different definition of consciousness. So, what would it be? Space. Very good. Very good. Space is everywhere. It's between galaxies, it's between universes most likely. It's between stars, it's between planets. And at the atomic level, the space is extremely high. Atomic structure, all of your reality is built out of 99.999999% space. So everything you say is so solid, is so real, that you think of as your reality is actually mostly space. And it's oscillating, and the oscillations interact, and did you know that you actually haven't touched anything at any time, anywhere? Nothing touches? Nothing? The densest atom is like, a molecule is a diamond molecule. If you grew one of the atom in that molecule, the other one would be 2 football fields away. If the one you grew was the size of an orange. That's how much space there is in between them, and then the space inside the atom is 99.99999%. So maybe we should pay attention to the largest percentage instead of the smallest percentage. We spend a lot of time paying attention to the 0.0000001% that we call matter, and we spend very little time paying attention and trying to understand the 99.999999% of the space. So maybe instead of matter defining the space, maybe it's space that defines matter. And I start to realize that. You all following me? This is a fundamental change in consciousness, to actually go in the world and first of all realize that you're mostly space, and that maybe the space is defining you instead of you defining it. So it was many years of studies in physics. Many years of studies in physics, some 15 years, and I did most of my studies independently because I didn't want to have to answer to anybody about the way I thought and what I wanted to think. And I had to finance it independently, so I actually lived in a van for almost 5 years at one point, so I didn't have to pay rent, and I could just study and study and study. Most of the people that write physics at that level, meaning most people that write physics in unification theory are usually in their 70s, 80s, because it takes a long time to learn enough physics to get to that level. But because I was inhibited by, having courses that didn't, go in the direction I wanted to go, or having to do exams and all this stuff, I was able to move very rapidly. Eventually, I got my first sponsor that took me out, literally, of my van. The deal with him was that I had to agree to go to physics conference. And, I wasn't so keen on that because I already had a bunch of run-ins with the physicists, and, I wasn't so excited to put myself in front, with like a big bullseye on my head. And so, but he dragged me there, and so this was a private conference, and I went there with this book called Gravitation. Gravitation is like the Bible of relativistic equation, Einstein field equations, and it's written by, giants of physics, Wheeler, Thorne, and Mesner. It's thought to be the Bible of relativistic physics, and it's called Gravitation because you can see it's quite thick, so when you pick it up, you know everything you need to know about gravity. And I was at this conference and I kept on asking annoying question. Why annoying? Because in advanced physics conference, usually you don't ask question that has to do with fundamental physics. Everybody there is supposed to have accepted fundamental physics, learned them a long time ago. They don't want to revisit it. You're supposed to be in like, 11-fold geometry of Calabi-Yau space, string theory, all this stuff is happening, really complex equation, and I kept on asking basic questions. For example, I was getting there. Gee. At one point, I pulled out my gravitation and I opened it on page 719, and I said, so if I understand well from all the equations that we've been studying, the universe model that we have today resembles a balloon, and this is actually the example they give you in physics text. And it's a balloon that's expanding that has pennies glued to it. And the pennies are representing galaxies. And as the balloon expands, the galaxies move away from each other. And everybody's like, yes, Nassim, that's correct. And I said, well, the part I'm missing, I'm sure I missed it. I'm sure, you guys can point me out to it and I'll just shut up from there on. But like, what I really want to know, and I haven't found it, and I've been studying a lot, and so what I really want to know is where the equation that explains who's this guy. And the whole room, I got a different, response. The whole room became really silent, I always remember there was a student, a PhD student there, and he went like, was drinking his coffee. And I could see the director of the physics department there started to sweat a little bit, and I think he thought I was going to say the word God in the physics department, it's like, oh man, please, not in front of my students. And so I said, hey, let's draw the rest of the guy, and notice that when the balloon expands, yes, the lungs must contract. For every action, there's an equal and opposite reaction. And that's, not being accounted for in our current physics. All of our physics today are based on expansion, explosion. It's the male approach to the universe. Our most advanced technologies, our most advanced engineers, and the people that we respect the most in science are people that make these phallic-like symbol large, cylinders. They fill them full of fuel, highly explosive material. It's our approach to space travel. And then, put a little capsule on the end, find volunteers, stick them in there, light the bottom, stand back and go, oh my God, I hope he survives the thing. Send them a few miles up, right? And then at the end it's like large cylinder, and then there's a little ejaculation. Poof! A few guys in there. We put fuel in our cars, we explode the fuel, we push a piston down, our car gets going. Everything's on explosion, but how does the explosive side of creation, how the entropic side of creation occur if there's no centropy? If there is no movement to the center, if there's no compression prior? I mean, for a fuel to come to exist, there must be dynamics that compress that energy into that fuel. Right? If the universe exploded from a point, smaller than an atom, which is the standard model of the Big Bang, which I'm not fond of, and I show you why, then something must have put that energy in there. There must be a compressive, there must be a collapsing form of the universe that's occurring at the exact same time as the expansion one. For every action, there's an equal and opposite reaction. And that is some of the fundamental physics. So, now, remember how we said, maybe it's the space, right? Maybe space is the part that's holding all the information. Maybe space, and this is certainly how I was starting to think, maybe space leaks a little bit of energy on the radiative side, and that's what we call the material world. But if that was true, if space is the thing that connects all things from infinitely big to infinitely small, then space would have to be infinitely dense. Wouldn't it? Well, is that true? I mean, doesn't seem like it. So I started to study more. And then I realized, and certainly at the time, now it's becoming more known, more popular, but at the time, something very, very dramatic had been swept under the carpet by physicists. That is that when we start looking at the quantum level, at the space inside the atom, that space is not empty, but is fluctuating at really, really high velocity, at really, really high density, like a lot of energy. It's not empty at all, it's a lot of vibration. When they try to calculate how much vibration is present in the vacuum inside the atom, this is what they found. Present-day quantum field theory gets rid by renormalization process. Renormalization, that's what they tried to do to me at school. Process of an energy density in the vacuum that would formerly be infinite. Let me say that again. An energy density in the vacuum that would formerly be infinite if not removed by renormalization. Right. So that means that the equations themselves showed that the vacuum density at the atomic level in the molecules and the atom are infinitely dense. That's exactly what I had predicted just using fundamental logic. You all following this? Space is not empty, it's infinitely dense. But because it's infinitely dense, then everything cancels out and it looks to you like nothing. Infinite mass. Meanwhile, we're floating in this. That would mean there's infinite amount of energy in the vacuum. And we've got a whole bunch of people on this planet going, dude, there's not enough energy for everybody. What are we going to do? We've got a war for it. Right? Well, then, when an equation gives an infinity like that, in physics, it's not acceptable. It has to be renormalized. That is, you try to find a constant that you can apply to it so you get a finite number. So in this case, and they did that to quantum theory in another way as well, they use this constant. It's called a Planck's distance. You can think of the Planck's distance as the minimal amount, the smallest wavelength that the universe can do, calculated from our physics using, electromagnetic theory and gravitational theory and so on. This is what we calculated is the teeniest thing that the universe can do. It's 1.616 multiplied by 10 to the minus 33 centimeters. So you guys all understand exponents? Like if 10 to the minus 33 means there's a decimal point, 33 zeros, So it's very, very small. Extremely small. Billions of times smaller than an atom. So, do I believe this is the smallest thing the universe does? Absolutely not. However, I believe that this is the fundamental boundary condition that defines our relationship to the universe. That is, from our boundary condition, from our scales, this is the smallest thing we experience. So they took that number and they said, okay, so how many of these little vibrations can I put in a centimeter cube of space? And that will give me a finite number for the density of space. You all following this? Good. Just making sure. So they made little vibrations of 10 to the minus 33 centimeters. They stuck them all in a centimeter cube of space. They counted them all, and since, for a vibrational rate, you can get a mass, how much it weighs. The mass of the Planck's distance is 10 to the minus 5 grams. Then they added all the mass and got a density equation for the density of the vacuum. You all followed this? So this means that the vacuum, it has a density of energy of 10 to the 93 grams per centimeter cube. Yeah, that's what I thought. Now you got to understand, 10 to the 93 is like a 10 with 92 zeros following it, right? Now you all notice in your bank account when you add a zero, things like, improve very rapidly. You got like 5 zeros and you add another one, it's like, oh yeah, this is good. Then you add another, oh yeah, I like it. Well, that's, keep going. Then you add another one, oh yeah, now I'm feeling good, right? So, imagine you got 50 zeros and you're still adding. So, imagine you got 50 zeros and you're still adding. So how dense is that? Let me give you an example. Yeah, I'm getting there. If you take a centimeter cube of space and you were to take all the stars in the universe we see with the largest telescope, Billions of stars, right? There's billions of stars per galaxies. There's billions of galaxies. Most stars are much larger than our sun. Some of them are larger than our solar system. And we grab those, like quasars and stuff, and we grab all that stuff. We squashed it all into a centimeter cube of space with a huge trash compactor or something. Imagine how dense that would be. How energetic that would be, right? Well, you would still be off by some 39 orders of magnitude, right? Because you would have a cube of a density of 10 to the 55th grams per centimeter cube. So you'd be off by 39. You still need to add 39 zeros to get to the density of the vacuum, which is formally infinite, right? Do you think that the physicists that discovered this stopped and said, hey, maybe we need to consider this in our physics? No. They looked at that number and said, oh my God, it's actually called the vacuum catastrophe. It's like, oh, what do we do? Just ignore it, brah. That's if you're studying in Hawaii, you know. If you're here, you'd say, ignore it, mate. Little translation for you guys. And, you know, all this energy just got pushed to the side and said, put under the carpet and said, hey, you know, this is too overwhelming. This probably has no significant physical meaning. Huh? You just found the most massive amount of energy ever, and you're saying it has no physical meaning? Most likely is the source of all physical meaning, brah. You know? If you're Hawaiian. And so, now you may say, maybe those physicists are insane. You know, how do I know that this is really there? You know, how do I know that these equations are just not like crazy equations? Well, because it was verified in laboratory. If you get two plates close enough together, you can push them together so that you eliminate the long wavelengths of the vacuum on the outside of the plates. And you retain only the small wavelengths in the middle of the plates. So the result is that there's more energy on the outside, less in the middle, so the plates should get pushed together. Professor in physics, Dr. Casimir, you know, came up with this concept in 1947. Should I play that again? And he thought, oh, that'd be a good experiment to put together. But in 1947, when he made the calculation, he realized the plates would have to be, you know, microns apart. In 1947, nobody could mill micron precision plates. So there was no way to get two plates that close together. It took until the 90s before we were able to do that. And then when we did, the plates pushed together exactly as Casimir had calculated they should push together based on the vacuum density, you know, that he calculated in 1947. So it's really there. Really, really there. And now physicists are more and more accepting that actually the fact that they're realizing the universe not only expanding but it's accelerating is showing that the vacuum at the universal level might be the thing that's expanding our universe. Now, I know you've all heard from other presenters that the universe may not be expanding. when I talk about the universe expanding, I'm talking about the movements of planets, the movement of galaxies in our universe that appear to be moving away from a central point. Do I think that automatically means our universe is expanding? No. What I mean is that it could be moving away from the center at the equator, and it could be moving back towards center at the North and South Pole. And we wouldn't know. And it gets a little more complex, and we don't have time to get into that, but we'll see some of the dynamics that produce that view. You know, we have a tendency to have an arrested view of the dynamics of nature. Nature is a little more complex than just a sphere. Just a little. And so, if this was true, then that means that our universe is driven by the vacuum, that the space between you and me connects us, that the information that is in the space divides in very specific scales, and those scales makes up all of our reality, and that we're part of those scales. You guys are following this? Instead of matter being some kind of entity that comes out of nowhere, matter is just the result of the division of the structure of space itself. And you are interacting with that structure every day, every second, every billionth of a second. We know that all the electrons and positrons in your atoms are going appear, disappear, appear, disappear, appear, disappear in the vacuum. Every time the electron comes out, it's learning about your experience and then feeding it back to the vacuum, and learning about your experience and feeding it back to the vacuum. You are informing the universe. You are informing the universe about your specific point of view on the whole thing. And I can demonstrate that mathematically. And that's why people in the spiritual world are saying, you create your reality. Okay? The part that's missing in that statement is the other part of the feedback loop. A fractal is a feedback. The other part of the feedback loop is that reality is creating you. The vacuum is defining your existence. So, because you know what? If we all created our reality independently, we would never meet. It would really suck. We'd all be alone in our own little universe we created going, where did everybody go? We'd be really bored because we'd create exactly what we want every time and like, right? And so, but that's not what's happening. You're feeding information to the vacuum, and since the vacuum connects us all, it has the information of everybody in it, and it's feeding you back an experience, right, that's in coordination with everything else. So that there's a consensus reality. So that one being cannot overcome all the scales. So that one person cannot say, oh, you know, today I'm kind of hot. Let's turn off, let's cool off the sun. And then the poor guy in Alaska is like, dude, it's cold up here. Right? But there is scale relationships. So the idea of the butterfly analogy, right? The butterfly in Africa that bats its wings and it makes a hurricane in Florida, right? That's found in many literature on complex theory, on the chaos theory. That concept is only true if you put it in the context of scales. You all following me? Like, meaning that if the probability of a butterfly flapping its wings in Africa producing a hurricane are really, really, really low. Actually, almost non-existent. Why? Because it would suck. You'd have people in Florida going to Africa with shotguns going, brah! Don't you move those wings. maybe if you have millions of butterflies all moving their wings at the same time, now you got something going. Right? So the morphogenic field, we're all connected. If we're going to move forward, we got to bring enough oomph to the system so that it can modify. Right? This is actually why I talk to people. Right? We have to move together. It is a consensus reality. And it's really important for people to understand that, because then, first of all, you take responsibility in what you're feeding the vacuum. But as well, you realize that if it's not all going exactly how you want it to go, is because you're embedded in a morphogenic field and you're interacting with all the stuff that's going on in it. You're all following that? So, be kind to yourself. So these scales, if this was true, then when I started to collaborate with Dr. Rauscher, which was one of the only physicists that would actually work with me. I'm just kidding. Somewhat. And she was retired. She didn't have anything to lose. So, she said, if you're right, I think you're insane, but if you're right, then we should be able to write a scaling law that shows that the vacuum divides in a very specific way. And so we wrote a scaling law where we plotted the radius of an object relative to its frequency, to its energy level. And we plotted all the things in the universe on it, that, the large things and the small things. And we started with the universal size. Now, I just want to let you know, if you take the size of our universe and you put all the mass we see in the universe, which is 10 to the 55th grams, right, in it, our universe obeys the condition of a black hole. That is, there's too much mass for light to escape it. We know since Einstein that light gets curved by gravitational fields. We were able to show that with stars that are behind the sun that appears to be beside the sun just because the light is curving. And so if you shine a laser at night, the laser is going out and is being curved by the sun a little bit. And it's going to get curved by another star a little bit, and another star, and another star, and another star, and it's not going to come out. It's got too much mass in our universe. We live inside a black hole. This is why it's black at night. Another story. And why is that? Well, because remember, if it's division to infinity and each division has mass, then everything must be a little singularity of infinite density. Everything must be a little black hole. Every atom you're made of. So when I made this calculation, I was very happy to see that matched. The mass of the universe to its radius gives the exact equation for a black hole density. And then I looked at quasars and galactic centers, and I plotted those, so their energy level to their radius, and they started lining up. And then I plotted stellar object, and it lined up too. Now there's nothing in cosmology that would predict that this should happen. And then I plotted the atom. So now that's a big jump from the sun to the atom, right, across quantum theory. And sure enough, the atom showed up along that line, and this is the Planck's distance. So everything lined up along that line, and this is the Planck's distance. So everything lined up nicely. And then I looked at the biological entity and found that microtubules, which are little structures that makes up your cell's boundary, okay, oscillate at 10 to the 11 to 10 to the 14 hertz, and when you plot their size, it almost bisects perfectly this, continuous line from universal size, the size of the universe, to billions of times smaller than an atom, everything lined up, including biology, which is you. You are in that mechanism. You are part of this conduit of information of the vacuum that goes from infinitely big to infinitely small through you. And as it passes through you, it picks up your specific interpretation of the universe and feeds it to the infinity of all things, so that your participation is counted. Do you start to get a sense of your responsibility? And so there, we start to feel that connection to all of the scales. But how do we get that feeling of that connection? Just a little side note on philosophy. We get that feeling of connection not by trying to connect with infinitely big. People say, I can't visualize that. Well, that's because your senses are fairly limited. But you have the infinitely small within you. So through that direction, you can connect to infinity. This is why most of the masters that have walked the earth have said, go within. The kingdom of heaven is within. The Buddha is within everything. The Bindu point is within everything. And it's your connection to all knowledge. Right? Right. Oh. You're all going, oh man, you mean I've got to sit in like some pretzel position every morning and like, oh. No pretzel necessary. You can do this sitting down anywhere, or standing up if you want to. You have access to senses towards the infinitely small, because you contain it. But when I wrote these equations, there was an issue. One of it was like, okay, if everything is different scales black holes, when I presented that to physicists, I got my butt kicked pretty hard. Typically kicked out of physics conference. Why? Because, I've got an atom in there that I'm saying is a black hole. Is the atom really a black hole? And that brings us to that paper I just published that's so controversial. And I assure you, I'm still dodging plenty of tomatoes and rotten eggs. Right? That paper is called a Schwarzschild proton, and it's kind of a bombshell. In very simple mechanical equations that I'm going to show you right now, I prove that the atom is a mini black hole. And how did I do that? Well, I looked at it this way. I said, I'm not going to do like everybody else and ignore the density of the vacuum. Okay? I'm not going to ignore the most intense, the most energetic, probably the source of everything, thing that we found in physics. So I said, inside a proton volume, right? The proton is like, let's say you have a simple hydrogen atom, you have a little proton, is the nucleus of the atom. It's very, very tiny in the middle. I said, inside there, how much volume is there. And so I calculated the volume of a proton. It's 10 to minus 39. Depending on which radius you take, it's an approximation. 10 to the minus 39 centimeter cube. And I said, how much of this energy that's in the vacuum is still present inside the teeny weeny beady proton? And I made the calculation, which is pretty straightforward. And the result is 10 to the 55th grams within a proton volume. There's still 10 to the 55th grams inside the volume of a proton. Where did we see that number? The mass of the universe. The mass of the universe. Now remember our assumption, remember our statement? The vacuum connects all things. If that was true, that would mean that you'd expect all the information of every proton in our universe to be present in each one of them. And that's exactly how the math came out. Isn't that cool? This is actually the mathematical evidence, I'll call it for now, that everything is one. Alright? Now, no longer just a concept, no longer a dogma, now it's a mathematical, physical evidence. Like that? Yeah, right on. I thought that was cool. I didn't mention it in that paper. I didn't talk about oneness, you know. Don't want to be too obvious in those papers. I said, oh, you know, this number is evidence that all protons are entangled. Right? You know? If you use physics terms, then they'll listen. And so, this is all nice, you know, this 10 to the 55th gram per proton volume. Remember, 10 to the 55th gram is enough to make the whole universe a black hole. So obviously, if I take all of that as the mass of the unit of the proton, no doubt the atom is a black hole. But actually, how much of that do I need to take? Very little. In fact, if I only use 10 to the minus 39%, a very teeny, weeny, beady little amount of 10 to the 55th grams of energy, the proton becomes a black hole. The atom is a black hole. And so in this paper, in some ways, you could say that I'm saying that the vacuum is feeding all atoms. That the material world is basically 10 to the minus 39% of the energy of the vacuum. It's just a little beady weedy leak, teeny weeny leak of the vacuum. And it makes up the material world. You all followed this? So imagine if we tap this energy that's in space everywhere, we don't even need to tap anywhere close to 10 to the minus 39% of it. You know, if we if we cohere that energy, get it to work with us just a little bit, just a teeny weeny bit, we produce enough power to power our whole planet for thousands and thousands of years. We can produce enough power to create gravitational fields, gravitational drives, travel across our solar system, travel across our galaxy, probably go from one galaxy to another or even one universe to another. We free our society from the bounds of being stuck to the surface of a planet, which is not a really good place to be. just isn't. Cosmologically speaking, surfaces of planets are highly unstable. They don't just hang out because there's people on it. Our atmosphere is equivalent to like if you took a billiard ball and put a little shellac on it. That's about the thickness of our atmosphere. And the earth beside the sun is like a little grain of sand. A teeny weeny grain of sand. And one of those big sun flare comes out in the right place at the right time and and everybody in the solar system goes, huh, what was that? Oh, that was Earth's atmosphere. All done. Next thing you know, it looks like Mars. Right? So, never mind, asteroids and comets and all the rest of the stuff. Right? So there is typically a cosmological time period in which a civilization like ours has to figure out how to get off their rock. And if they don't, on time, well, on to the next round. You see what I'm saying? This is a fundamental step that a civilization must do. And we are at that point. We are at that moment in our evolution where we must understand these more fundamental principles of the physics of the universe that includes the philosophy of the universe, the spirituality of the universe, the connection that connects us all, and understand how it works and apply it in our technology so that we can actually, literally ascend. So, after all this rant, if I use 10 to the minus 39% the mass of the mass of the vacuum to make the atom an uni black hole, all of a sudden my atom is a heck of a lot heavier than the atom that's measured in laboratory. So the mainstream is really not happy with that. You can imagine. In fact, my atom is 10 to the 39 orders of magnitude larger than the standard proton. So, you would think, oh my God, it's got to be wrong, right? 10 to the 39 orders of magnitude wrong. Right? Well, the first thing I did, I said, well, if I'm that wrong, this, it shouldn't work in a scale. So I took a scaling law. This time I took the mass against the radius, and I put all the objects in the universe I could find. Universe, this is the Planck's mass, the Planck's distance, and then, galaxies, quasars, the sun, the earth, pulsars, and this is the Schwarzschild proton, this is the black hole proton, and this is the standard model proton. So, this is straight off data. This is not really debatable. Obviously, this data point is in the wrong place. Why is that? It's because our way of measuring the mass of the proton, and just so you know, in physics, mass has not been defined. They don't tell you where it comes from. Right? Is to knock the proton out by shooting particles at it. And then it pops out of the atom, and then we make a measurement, and we assume that the proton was the same mass when it was in there. Well, when you've disturbed the system, you probably don't get the right data. It's the same thing in you probably don't get the right data. It's the same thing in biology. We want to study cells, so what do? We freeze them with liquid nitrogen. And then we shear them open Now they're not alive anymore, you know. And then we look with an electron microscope and, oh wow, you know, DNA is a big mess in there. We're probably not getting the right data. And so, why is it that, I just want to make a point, that this excess mass is because it's actually in the mainstream theory, it's just they don't know about it. And the reason why is because when they found two protons, they said, oh my God, protons are positively charged, so they should repel each other inside the nuclei, like two magnets would repel each other if they have the same charge, right? You're all following this? Well, when they found this, they said, oh, you know, gravity couldn't squeeze them that hard. There must be some unknown force. And the next thing they did is they invented a new force almost 100 years ago. They called it the strong force. It's very convenient. And then they put it in there and they made it exactly the strength it needed to do to push the protons together. Ha! I call that physics as you go. They did the same thing with the universe. They found their equation only predicts 4% of the universe, missing 96% of the universe. Instead of revising the equation, they said, oh, we'll invent dark matter and dark energy, throw it in there in the right percentage. Look, the equation works. Must be there. Physics as you go. Right? So then, you know, when they invented this strong force, then the next thing you know is they can't reconcile the strong force with gravity. They can't put the two together. Right? So now they have this big dilemma, and now they keep adding dimensions to try to make it work. You know? It ain't gonna work because the strong force does not exist. It's a figment of our imagination. It's gravity acting at the atomic level. You're dealing with mini black holes. That's why the electron spins at near the speed of light. Right? So, if you take two of these protons, little black hole protons, and you calculate their strength, I'm going to spare you the equations. Although you could easily follow them because they're simple. The force between two black hole protons is very large, so it can overcome the repulsion. But then you calculate how fast two protons like that with that force would rotate around each other. And you find that you know, they rotate at very high speed, 10 to the 32 centimeters per second square, very rapidly. And then you calculate, that was their acceleration, you calculate their velocity, and V turns out to equal 2.9 multiplied by 10 to the 10 centimeters per second. Anybody recognize that number? Very good. The speed of light. V equals C. So now, these little protons at the center of the atom are not only infinitely dense, but they're spinning at near the speed of light. They're spinning at very high velocity, near the speed of light. So you know all these masters that walked around saying, you are light? They meant it. Can you like visualize yourself? Can you sense yourself? Can you sense your atoms as mini black holes spinning near the speed of light? This is how dynamic you are. This is how energetic you are. It's an amazing thing. You're transferring information to the universe and back at the speed of light. You're flickering really, really quickly. Push the vacuum, to the vacuum, back out, to the vacuum, back out, to the vacuum, back out. So who are you when you're the vacuum? Have you explored your vacuum self? You know, please don't talk to your shrink about this because it might put you some nasty drugs, you know. Bro, you're bipolar. Yes, I am. I'm sorry about that. Half the time I'm the vacuum. I don't think they have any drugs to stop that one. So, you know, I can skip some of that, but I just wanted to say, you know, you're informing the vacuum, flickering in and out of it very, very quickly. Everywhere is happening like this, you know. It's, my 4-year-old actually talked to me about that once. But, you know, it's really a remarkable thing, and it's really important to become aware of this interaction. And when it's happening, you start to realize that maybe linear motion is not quite what we think it is. What I mean by that is that if we live in a fractal universe of infinite division, from infinitely big to infinitely small, then movement from point A to point B is quite different than what we assume it is. Okay? You can start to look at your hand and say, okay, my hand is going from point A to point B. And I'm going to calculate how fast it did that. Well, you know, if you close the box around your hand, then you can do it. But if you realize that it's all embedded to infinity, then you'd say, well, while my hand was going from A to B, the Earth was rotating. So I got to add that speed. And then while that was happening, the Earth was rotating, then the Sun, it was rotating around the Sun. So I got to add that speed. And then as it rotated around the Sun was moving through the galaxy. So I got to add that speed. So you know, your hand is now moving at millions of miles per second, you know. And then like, you know, you keep adding because this galaxy is in a supercluster, which is in a in a cluster, which is in a supercluster, and so on. In a universe, in a multiverse. Next thing you know, your hand's going at the speed of light. So how do you define movement? You realize that your hand is not moving linearly from A to B. That's the chopper that likes to follow me. Your hand is appearing, disappearing, appearing, disappearing, undoing itself, redoing itself, undoing itself, redoing itself, every time going to infinity and back. Being informed of where it must reappear. Just like a movie, where there's a bunch of frames, but if you move the frames fast enough, they appear to be smooth. And if you realize that, you're interacting with the vacuum this way, and you're good at manipulating the vacuum, what I call vacuum engineers, masters, you might be able to get your hand to disappear here and reappear over there. And skip all the points in between. Now if you did that, you want to make sure you brought your body with it, because it could be uncomfortable on this hand with missing the rest of your body. So, this understanding, this technology, this capacity to interact with the vacuum, both in your own being, but very specifically in laboratory, leads to technology that will blow your mind. Leads to technology that not only brings us to a capacity of abundance of energy, infinite amount of energy, space drive and so on, but to actually transfer the information from one end of the galaxy to the other end of the galaxy without having to go through all the points in between. And I assure you, although that might sound like far in the future, all this is just around the corner. Now, you know, I wanted to show, well, you know, when you make the calculation, you get the magnetic moment of the atom, and you get all the things you would expect in the atom. But I wanted to say a few things on ancient civilization, because when I did this research, I was studying in parallel a lot of ancient civilizations. And the reason is that I realized that if this vacuum structure is really there, if the vacuum is polarized, if it's not just a random mess, as in defined in quantum theory currently, but actually is the source of the organization of everything, then it must have geometry. It must have a fundamental structure, and we need to understand what that structure is. And as I studied ancient civilization, these guys kept on pointing to very fundamental geometries. And they all said, this is the geometry of creation, it's everywhere, this is how creation occurs. And you can find it in almost every ancient civilization around the world. And then they built they built. Let's use that loosely. They might have got some help. You know. And very specific geometries all around the world with very specific, intense, focus on very, important texts that describe this geometry, this fundamental geometry of the vacuum. And I spent many, many years studying them, and I realized that there was a code that was left here by many ancient civilizations. And I really don't have time in such a short lecture. Most people have been to my lectures, they're usually 10 hours long, to actually get into that part of the knowledge. But it is evident when you do the research, and you can get my DVD set, and it has like 8 hours of this information. You can get it at the table, you can pre-order it at the table. And I discuss all this because when you look in all these ancient texts, in all these ancient civilizations, it talked about this geometry and gave us all the mathematics, all the equation to solve it. And even give us some technical knowledge how to build it in laboratory. And do I think that ancient people came out just out of osmosis? Absolutely not. Evidence supports very widely that there was some advanced civilization around here that were attempting to give us some knowledge about these things. Some of those guys. This is in Russia. They just found these skulls not so long ago. And that the geometry was fundamentally embedded in many different ways. This is actually on a pillar in Egypt. It's not etched, it's not carved, it's somehow burned into the atomic structure of the granite pillar in Egypt at the Osiris temple. Then you go to China. The food dog is the guardian of the knowledge. He guards the knowledge under his paw. And then you look under the paw, and sure enough, you get the same geometry. And this geometry that I'm talking about is very fundamental, and it is a geometry extrapolated from writing concepts of the structure of space-time that demanded a fundamental geometry that could produce all of the rest of the geometry we see in our universe, in our biology, and in our organization of the universe. And it's based on tetrahedrons. It's a 64 tetrahedron grid. We have talks coming up for the next 3 weeks, so please come to our talks. There you go. Thank you.
Watch this. Come back in half an hour. Thank you again, Nassim. That was great.